Hi, this is Jason Molesky. In this example, we'll explore an experiment that involves blocking. Women and men respond differently to advertising. Researchers would like to design an experiment to compare the effectiveness of 3 advertisements for the same product. For this problem, we want to explain why a randomized block design might be preferable to a completely randomized design. Then, we want to outline a randomized block design using 300 volunteers, 180 men and 120 women as subjects. We'll want to describe how we carry out the random assignment required by that design. Well, for a complete describe how we
Ryan, was it you that just asked a couple minutes ago, or somebody? Ethan, when you said, would it ask for a suggestion on what to do?
Yeah.
Sometimes it's really hard to recall what you should do in a particular situation, but many times you'll be asked, why is this one preferable over that one? So that at least giving you like a nudge in the right direction, like randomized block design is the best avenue here, but why is it better than another? That's usually how things are phrased, rather than, okay, blank slate, you're on your own, conducted an experiment. So,
Head start. Yeah.
carry out the random assignment required by that design. Well, for a completely randomized design, we note that it considers all subjects, both men and women, as a single pool. Now, random assignment would send subjects to 3 treatment groups without regard to their gender. This ignores the differences between men and women, which would probably result in a great deal of variability in responses to the advertising in all 3 groups. A randomized block design, on the other hand, would consider women and men separately. In this case, the random assignment would occur separately in each block. Blocking controls for the variability in responses to advertising due to gender, allowing researchers to look separately at the reactions of men and women, as well as to more effectively assess the overall response to the advertisements.
I'm trying to pause it before the little diagram came up. So, we just had an example with cell phone users, right? We had 2 different blocks. We had cell phone users and non-cell phone users, right? So that's where they splinter. And then the cell phone users were splintered again. Into what?
2 different types of keyboards.
2 different types of keyboards. That's the treatment. You with me? Do you see it here? What are the 2 blocks? Men and women. And then and then on the branch of men, that's going to splinter into how many?
3.
3. See that? So we're really going to have 6 different things going on here. 3 of each type of gender. Okay? So it goes out, branches out, and then it branches back in, and then we analyze the results. So it's helpful that when you guys see a ceremony, if you can... Ceremony? What was I meaning to say? It's helpful when you see an... I don't know why ceremony came out. It's helpful when you see an example as you're reading it. Something was going on there. That you're able to kind of see a diagram develop in your brain. Yeah.
Overall response to the advertisements. Now, to carry out a block experiment, the first thing we'll need to do is randomly assign the 120 women into 3 groups of 40, 1 for each of the advertising treatments. We'll give each woman a distinct label between 1 and 120, and then we'll use a computer's random number generator to sort those numbers in a random order. The women with the labels corresponding to the first 40 numbers on the list will view advertisement 1, the next 40 view advertisement 2, and the last 40 view advertisement 3. We'll randomly assign the 180 men into 3 groups of 60 using a similar process. After each subject has viewed their assigned advertisement, we'll compare their reactions within each of the gender blocks. Now, for some additional practice in describing a blocked experiment, try exercise 77.
Wow. 120 and 180. Each block doesn't have to have the same number. You may say, that's not fair, that's biased. That's a whole different issue. Okay? So they do this on purpose to try to show you in the beginning that the number in each block doesn't have to be the same. Okay? So let that be known, because some students see that in the very get-go and say, oh, well, the sample sizes are not the same for each one. It's not practical or feasible sometimes when you're doing an experiment to get equal groups. What matters is that you have a large number in each group. Okay? But notice that each group, the random assignment was 40, 40, 40, and 60, 60, 60. That should be equally split up. So you heard the man. Try number 77. In a minute, you're going to subtract two numbers, and then you're going to give me your result of that. And then I'm going to do a dot plot, and we'll talk about it. You're going to be doing a stand number minus a sit number. Okay? Now I'm going to ask you to take your heart rate in a minute, and we're just going to do 15 seconds, and then multiply by 4. You with me? 4 times 15 is 60. You with me? So since Spencer's already standing, we're just going to have this side of the room stand with Spencer. You guys sit. Stand.
You're welcome.
Okay, when it gets to the 12, we'll start taking our pulse, so I'll tell you when. 5. Ready, set, go. Okay, stop. You're going to multiply that number by 4, and you guys will be writing it here. You sitting people are writing your number here. You with me? So, did you guys take your pulse too?
I think I did it.
Yeah. Take your pulse.
I got 7.
Okay.
Okay.
Now you guys sit down. Okay? You guys sit down, and you guys stand up now. Now, sorry if I didn't make that clear. So everybody's taking their pulse no matter what. Now you're going to be taking your pulse. Let's wait until it gets to the 3 at the 15. Okay? Just so yeah, we'll wait 15 more seconds. There comes our influential point. She was out running around, so we're going to throw at her. Okay, so 5 seconds, then we'll start. Ready, set, go. Okay. So the order of those numbers are going to matter. You're going to do stand minus sit. So what was your standing pulse and your sitting pulse? And you're going to subtract. Make sure you give me that order. Okay?
No, I didn't know. I got 20 as a difference.
So stand minus sit. You with me? Okay, so Spencer, what was the difference of your
12.
12?
Yep.
12? Okay.
Are you a little stressed out?
Anybody else over 5?
Over 5?
Yeah, okay, well I need to change my scale here. Duh, yeah, that's right, sorry about that. Yeah, for me, yeah, definitely.
Okay, it was 8.
Okay, so, here we go. Anybody higher than 12? What?
20.
20, okay. So, anybody higher than 20? 20, okay, so you got 2 dots there. Okay, so
Mine was 20, but then I redid
we
it.
have to be 16, right? Just comp one down. Okay, so, Kelsey? 12? Yeah. 4? Okay. What'd you get? Mr. Rowe?
4.
4?
16.
16?
16.
4?
4.
8.
8?
4. 4.
4?
8.
8?
6.
0? She's our cool cat here. Doesn't matter. Negative 4? Okay.
0.
0?
4.
0.
0? Another 0? No praise.
4.
4?
4.
Which really comes down to like one more beat. Within, you know what I mean? Okay.
Yeah.
So there's some, yeah, okay, go ahead.
8.
8, okay.
4.
4,
Oh, that was sorry. 0.
0,
Okay.
0, 8, okay.
8.
8. Okay, so we had one person that actually had a lower heart rate than when they were sitting. Okay, so this is called a matched pairs test, an experiment. First of all, a matched pairs, you did the experiment twice, but in 2 different fashions, and instead of graphing both heart rates, we just took the difference. See that? So that's the first ingredient with a matched pairs test, is you subtract the 2 numbers. Okay? Also, notice that I had 2 different groups reverse the order of because potentially the people that stand up are exerting energy when they get up, their heart rate goes up. People that were standing, they sit back down, they're more relaxed. So there is some breakdowns in the experiment here, but it illustrates a point. Number 1, a matched pairs test is a type of randomized block design. So make sure you underline that or circle it on the slide here. A matched pairs design is a type of randomized block. They're not 2 different ones. It's more specific. Okay? So if everybody in the classroom got 0, we could pretty much conclude that the heart rate of standing and sitting is the same. You with me? So since we have most of the people above, that the heart rate, we're pretty convinced that the heart rate of standing, your standing heart rate is higher than your sitting. Okay? So let me project the slide here, and we'll make sure we understand. Just in case you cannot see the language on your paper, I will project it for you. So sometimes a pair consists of a single unit. In the experiment I just did, what was a pair? 2 different readings. You with me? But it came from a single unit, you being the single unit. Okay? So that single unit has to receive both treatments though. So for this to be a true matched pairs design, both units, or each unit has to experience both treatments. But what you want to do is you want to reverse the order, like I did. Okay, so I didn't have everybody stand up and then everybody sit down, so I randomized that. Okay, so be looking for that on in the future, that a matched pairs has to have. Just think back to this example or this activity. Now, what you did with the numbers and how we did it, that illustrates a matched pairs design.